Hajune Choi, and my partners are Pranesh Macha and Mathew Allen. So our research question was what brand of bottled water contains the most amount of microplastics per volume of water? And so our a little bit of the introduction. So microplastics are consumed by aquatic animals, and then it could be transported into humans. Not a lot of research has been done on like how microplastics affect humans. So the purpose of our research is to figure out which uh, which bottled water contains the highest amount of microplastics. So for the methods, we obtained 400 milliliters of like these water bottle brands, and then we sampled them through a Buchner funnel using a PCTE filter. So we removed the filter after we filtered everything, and then we placed it in a petri dish to dry. And while we let it dry, we prepared the now red solution by diluting zero point 0.5 milliliters of now red and 10 milliliters of acetone. And so once it dried, we added 2 to 3 drops of now red and onto these PCTE filters, and we let it dry for another 5 minutes. And then we closed up the petri dish, labeled it, and then we handed it to our TAs so that they could go under the fluorescence microscopy. So we obtained those pictures, the microscopy pictures, and then we decided to like count how many particles slash microplastics there were.
So really the purpose of the now red dye was we were trying to isolate the inorganic particles in the bottled water. So when we use fluorescence microscopy, if a particle, for example, if a particle, for example, turned red under the scope, then it was considered an inorganic compound or was not natural to the water source. But we really didn't find much. For the one that had the most actually was deionized water, which was our control group, which we expected to have 0 particles. But as you see here, it had 20. But if a substance only fluoresced under green, then it was considered inorganic particle, maybe something like a microplastic. But if it fluoresced under red and green, then it may be something that, since we got our deionized water or our control group from tap water from a faucet, we just assumed that may have been rust, and that's what the case was. But for the Dasani fluoresced under red, but not green. So that was also maybe just organic particle that fluoresced on its own. But for smart water, we have smart water here. You can see, this is kind of not a good picture, but you can see that there's one particle here that fluoresced under red and green. So there may be a situation with smart water's filtration system. But based on the results, you can see that Dasani had 1 particle. Aquafina, which was the cheapest brand, actually had no particles, which we did not expect at all. We expected the water bottles that cost the cheapest to have the highest number of microplastics in them. So Aquafina had 0, Smart Water had 1. Kirkland had 2. Fiji had 3. Fiji had 3, which was one of the highest, where it cost the most water bottles. And a Brita filter, we filtered regular tap water through a Brita filter, and it had 1 particle that fluoresced under red and green. So we don't know if it's just a microplastic or any other organic material that could have came from the filter itself. So our research really came back inconclusive for finding anything too significant. So to improve our research, we determined that we could either use a larger sample size or we could do multiple trials or do both together. Any questions?
Hey, I have a few questions.
Okay.
So my first question is, you talked about how you could probably get more conclusive results if you tested, or if you had a greater sample size, or if you had more trials. How many trials did you have, and what would you think would be a good enough size?
So we actually did one trial for each because we did this in the lab, so we had limited time. So we did one trial each. I think a great sample size would be honestly around like a whole pack of like bottled water, like 24 pack. I don't know how many milliliters that would be, but I think that would be a good sample size.
Okay. And another question I have is, did you test tap water? I know you said you used a Brita filter with tap water, but did you test tap water alone?
We did not use tap water. We used deionized water that came from a tap in the lab room, but we did not use straight tap water that you use out of a faucet.
Okay. Did you have any reasons for not using tap water?
Mainly the time constraint, because this is for a
Okay.
class project, but
Okay.
that's really the reason.
And just two more questions, sorry. The first one is,
Yes, ma'am.
how do inorganic compounds affect the water source? Are they harmful? Are they good? Does it depend on the concentration?
I think the higher the concentration, the more it affects you, but we do not know. We've researched, but there's not a lot of research to determine how microplastics, because I guess they haven't been consumed in a high enough consumption to determine how they affect human consumption.
Mhm.
But we found a lot of microplastics in natural water, bodies of water, like the Cahaba River. We found a higher concentration of microplastics there, but because obviously the water already has a filtration system before they get to us, we just wanted to see how many microplastics were left due, or how effective their filtration system was.
Okay. And I think I had one last question. Um, so again, this is just like a final thing that I'm trying to understand. Do your results mean that these water sources are good, bad, healthy?
Since we couldn't really determine what kind of particles were in the water, I
Mhm.
don't know. But since I know Fiji has a slogan saying "untouched by man," so it would kind of make sense that it had more inorganic particles in it than, I guess, Dasani. But what we thought was the more expensive the water, the more particles it would have, meaning the cheaper ones would be worse for you.
Mhm.
But Aquafina was 89 cents, where Dasani was $2.39, and it had
Mhm.
zero. So I can't tell you if the more particles, the worse it is for you, because we really don't know what the particles are.
Okay. What do you think it might be? Or like, how do you think you'll go from here? If you could further expand what you've done here, what do you think you would do?
So firstly, I would like to get a bigger sample size for all my samples and try to figure out, I don't know how I would now, but I would like to figure out exactly what kind of particles are in those water bottles. If it's from us, it could have been from us, like from lint from our clothing or something like that. Or if we just see more and more of what's inside, then we could determine which water bottle is actually the best and which one has the best filtration system or which one has the least effective filtration system.
Okay, those are all of my questions.
Okay. Did I answer everything you got?
Yeah, you answered it very well.
Thank you.
Are there any more questions?
Can y'all hear me?
Mm-hmm.
Okay. My question is, when you realized that the deionized water had so many particles, did that change the course of your research questions?
So it kind of confused us a little at first but knowing where it came from, our TA helped us out a bit and gave us his thoughts of what it may be. So it really didn't influence us too much. But if we could have got deionized water from a different source, like I guess Publix, that's what we would have put in there instead of the one we found from the tap.
Okay, thank you.
Any more questions?
One more thing.
Okay.
The deionized water, did you get it from a tap from the Birmingham area, or where?
So in our lab, there was a.
Oh, we were in a chemistry lab here at UAB.
Okay.
I think you're muted.
The audio just went crazy.
Okay, I guess that is all. Thank you guys. Y'all did a great job.